Let's go ahead and move on to page 2 of our section 8.1. Notice now there are 3 functions, so we have to pay attention to which ones they're asking us. So there's f, g, and h. So this first one is f of x plus g of x. So this is just like what we've been doing, actually easier. If you haven't done one on your own yet, you should stop the video right now and do this one because this is good practice. It's a little bit easier than the last one, but you should try and get at least one under your belt before you go and do your homework. So f of x is x squared plus, and I don't need parentheses around it because it's a single item, g of x is x squared minus 4. And we know both of these have 1's in front, so 1x squared plus 1x squared is 2x squared minus 4. So there we have it. Piece of cake, huh? Next we have f of x minus h of x. So f of x is x squared. No parentheses needed because it's a single term, but h of x is 2 terms, so make sure you enclose those in parentheses. So f of x minus h of x. Again, we need to distribute. So that would turn into x squared minus 1x minus 2. And there's no like terms, so that's just our answer. But like I said, that was one of the most missed problems on the Chapter 4 test, was not distributing that. So always make sure you do this and distribute it out before combining like terms or doing anything else. Okay, our next one is g of x times g of x. So we can multiply something by itself, right? So g of x is x squared minus 4 in parentheses times x squared minus 4. So what kind of problem is this? What's it called? 2 terms by 2 terms. Boyo! So from f, we get x to the 4th. From outer, we get negative 4x squared. From inner, we get negative 4x squared. And from L, we get positive 16. Notice the middle terms do not cancel. They're not opposites, so don't cancel those. So that would leave us with x squared. Whoa, Nilly. X to the 4th. That's crappy. X to the 4th minus 8x squared plus 16. And there we have it. So used to putting x squared as the front term, I just wrote it right off the get-go. So those two, negative 4, negative 4 turned to negative 8. And remember, we do not add exponents in addition. And then last we have g of x divided by h of x. So g of x, look at the factoring there. What kind of factoring is that? Difference of squares. H of x is x plus 2. I can see something's going to cancel. So I'm going to switch colors because we're getting too close to those other ones. So the numerator, we know how to factor a difference of squares. We did know. Add the square roots and then subtract the square roots over x plus 2. So x plus 2 divided by x plus 2 cancels out, so we get x minus 2. But then we have to say, provided x does not equal, what would make this denominator 0? Negative 2. So anytime there's a denominator, we have to tell them what the restriction box is. X cannot equal -2. And this is supposed to be a plus and a minus. I'm sorry that got messy there. But that told me the signs were different. We do add the square roots, then we subtract the square roots. So make sure that is not a plus sign there. In fact, I'm going to try and get rid of it. Can I? Not very well. Sorry. I just don't want anybody to copy it incorrectly. There we go. That looks a little bit better. Okay, so let's learn our next new thing in this section. Well, actually, the first thing wasn't new. It was from way back in chapter 4. But this next thing will be very new. A lot of students don't even remember doing this in high school. So composition of function is when we place one function into another function. So this is a symbol for composition, F composed with G. But the minute we see that, we immediately write it with nested parentheses because we don't really know what to do with that notation. That does not mean multiplication, by the way. It's an open circle. So to write it in nested parentheses, you keep it in the same order. F, parentheses, G, parentheses, X, parentheses, parentheses. So you just keep the same order. And as we start working this, you'll see why this is a better format, because we know to start with the innermost parentheses and work out. When it's like this, you don't even know where to start. So it's F compose G, or the composition of F and G. And we have G of X has to be in the domain of F. So we'll talk about that in a little bit. So here's F of X, here's G of X. So they want us to find F of G of X and G of F of X. And just because I say of, if you remember, if you came from 09, we learned that compositions don't mean multiplication. So when I say F of G of X, that does not mean multiplication. It actually means turn it into nested parentheses. So F parentheses G parentheses X parentheses parentheses. And I like to do one more step, and students say it makes so much more sense if you do one more step. So G of X is on the inside. So I'm going to take it out and replace it with what it is. So whenever I do that in class, students go, oh, now I get it. I go into F. Everywhere I see an X, here and here, I replace it with this. Because remember in 09 or previous algebra classes, you learned this is your X. So everywhere you see X, you replace it with X plus 1 squared plus 5, X plus 1 plus 4. And this is a quantity, so notice every time I input it, so I put X plus 1 here. And don't forget to take out the old X. So this is the new value for X. So everywhere you see an X, you plug in X plus 1, and because it's a quantity, it does need to be in parentheses. And this is usually where most people miss this on the test. They forget that this is FOIL and they write X squared plus 1. Don't do that. Not this late in the course. You should not be doing that. So when you FOIL that, you get X squared. 1x plus 1x is 2x plus 1. So that is FOILing whenever you have two terms squared. This turns into 5x plus 5, and then we have our plus 4. So combining like terms, you get x squared plus 7x plus 9, 10. So we plug one function into the other function. That's why they're called a composition, because now they're made up of two functions. And then you get a totally different answer when you go backwards. So switch the order of G and F. So now it's G parentheses F parentheses X close close. So this means Remember how I said I always do an extra step and then students say, oh, that makes so much more sense. Take out f of x, put in what it's equal to, x squared plus 5x plus 4. So this means go into function g. Everywhere you see an x, and I only see one, replace it with x squared plus 5x plus 4. So x squared plus 5x plus 4, and then the plus 1. So now it turns into x squared plus 5x plus 5. So you plugged function f into g, and that's why it's called a composition. So you're probably like, oh my gosh, my brain is hurting. So let's do one together. Then you can turn off the video and try one on your own, okay? And notice these two answers do not come out the same. This isn't multiplication. We can't say, oh, commutative, same answer. Not true. The only time they're the same answer is if they're inverses, and usually they don't give us inverses to practice on. So for this one, we start our nested parentheses, f of g of x, close, close. So that's what students call it fog. That's what fog means. F of g of x. So this is a make or break it step. I'm telling you, if you do this next step, you will think these are super easy. So this is it. So we go inside the parentheses, we take out g of x, and we replace it with what it is. It's x minus 7. And then all of a sudden you go, oh, I get what they want us to do. They want us to go into f, wherever we see an x, replace it with x minus 7. So once you write it in this format, as long as you've had some experience with functions, which you were supposed to, it was a prerequisite to this class, then that should make sense. Go into function f, wherever you see an x, replace it with x minus 7, because what's in parentheses is always your new x value. So you take out what's inside, replace it with its equation. So this is going to turn into, so this says go right here and replace that x with x minus 7. Well, it is a quantity, so it has to be in parentheses. So take out the old x, put in the new value for x, keep your squared, plus 9. And like I said, this is usually where students miss it, right here, because they write x squared plus 49. That is not what x minus 7 times x minus 7 is equal to. This is FOIL. It's way back from chapter 4, so make sure you're not missing that now. So you write it out twice, and you FOIL. So can't distribute because of plus and minus. So that turns into x squared from f, outer minus 7x, inner minus 7x, last plus 49, and then plus 9. So that answer is going to be x squared minus 14x plus 58. So see, it only uses old stuff. It's new notation, but it's all old stuff we're using to work it out. So we already know how to FOIL. We already know how to do substitution. We already know how to add like terms. It's just now it's a new notation. So write x minus 7 twice, FOIL it, put your 9 at the end, then combine like terms, and that's how we get our answer. Okay, so let's see if we can get that last one in. I don't know if we can, but we'll try. So it's g of f, which means g of f of x. So now we take f of x out and we replace it with what it is, x squared plus 9. So we're finding g of x squared plus 9. So take it, whatever's inside out, replace it with what it is, and now you go into g, and wherever you see an x, you're going to plug in x squared plus 9. So this is x squared plus 9 minus 7, which is x squared